Hey everyone, welcome back. In this video we are going to start creating our player and getting it to move around. So let's start by making another new scene. File, new scene. Again, that basic 2D built in. And again, we're going to save it right away into our scenes folder. And this will just be our game scene. Let's go ahead and add that to the build profile, that scene list. Same thing, open up the scene list and add open scenes. And then let's import those assets from our course files. So if you haven't gone over to download those files, go ahead and do that. And then we're going to go to Assets, Import Package, choose a custom package. And then wherever you downloaded those, go ahead and go find them, open it up. It's going to pop open this other little window here, making sure that you can import the assets you want and whether or not it's going to overwrite anything in your project already. So everything here is new. That's good. So I can just click on import. All right, so I'm going to start by making an empty game object in my hierarchy here. I'm going to call it my player. And I want to make sure that its transforms are zeroed out, that they're at the origin, and nothing's rotated or scaled or anything like that. And then I want to go get some stuff from, or I want to get the player sprite from my art folder. This little guy looks like that. It should be single, it should be pixels per unit. That's one of the cool things about importing from a Unity package instead of just dragging and dropping in an image that you find on the internet, is I can give this stuff to you. So let's take that player sprite and I'm going to drag it as a child of the player game object. So this top level player, this top level object is going to be where all the components are. So like the rigid body, the circle collider, the player script that we'll make is all going to go on this top level object, and then the art is just going to go as a child of that, and it'll follow along with the rotations and stuff from the top level one. So actually I can rename this player sprite just so it's a little different. So like I was saying, on that top level player game object, let's add a rigid body 2D. Let's drop its gravity scale down to 0. I don't need this falling out of my scene. I'm going to add a circle collider. Looking here, that's actually too big. So let's drop that radius down to 0.35 looks good. And then I do need to make a script. So I'm going to go to add component. I'm going to type in the name of the script I want to make, which is player movement. I'm going to make that a new script. That's the name I want. I'll create and add that. And then I'm also going to go ahead, once this compiles, and in my assets folder in my project, I want to make a scripts folder, just so I can keep my project window nice and tidy here. And once I move that, it's going to recompile again. So all my scripts will go in scripts. I've got these scenes all in the scenes folder. All of my art is in an art folder. All the sounds are in sounds. All right, so let's open up player movement, because this is already attached to my player. And we're going to do some stuff that should look familiar. Let's start off with a public float for our speed. We need to multiply by some values. Let's start with this at 5f. I also want a reference to my rigid body 2D component. I'm just going to call that RB. So then in start, I'll set RB equal to get component, rigid body 2D, add those parentheses for the method, and the semicolon. Then, instead of update, I want to, this time we're going to be moving our player with physics. And generally, anytime you're using physics, you want to use fixed update instead of the regular update here. So I'm going to add the word fixed in front of update here. So now I have a fixed update method. This gets called based on a fixed frame rate, just so that all the physics calculations get calculated nicely. And then from there on, we're going to do some, again, similar stuff. I'm going to set up a float for my horizontal movement. That's going to be set to my input.getAxisRaw. Just want the raw axis. I either want to move or I don't want to move. We'll set that equal to the horizontal axis. And similarly, we'll make a float for our vertical. The get axis raw from vertical. We're going to put those into, this is going to be a little different. I'm going to start with a vector 3 called, let's call it direction. I'm going to set that equal to a new vector 2. So we're creating a vector 3, but we're only setting the first two values of this by setting it equal to a new vector 2. Inside of that vector 2, we'll give it horizontal and that vertical, H and V. And then I'm going to do something else here. It's called dot normalized. All right, so we do this normalization because with a vector, if you have, all right, so let me bring this over to illustrate my point here. We're measuring vectors, and if this is 0, 0, if we just press up, and let's say we go from 0 to 1, that is, the distance to that is just 1 unit. Same thing if we go to the right. We'll get 0, 1, and that's still just 1 unit. But what if you press up and right? So we get to 1, 1. Basically, we're making kind of a triangle. So if we go, if a squared plus b squared equals c squared, then 1 squared plus 1 squared is 2 squared. So this is actually the square root of 2, which is greater than 1. But we're adding those together and we get a larger number than just either one together. When we normalize, that kind of makes it into a circle. So it kind of cuts that off so that the distance when we press both of those will only ever equal 1. All right, so that's why we need to do this dot normalized. Then we can access our rigid body, and we'll get its linear velocity. We'll set that equal to our direction times the speed value from up at the top, and again times time. This time instead of delta time, we're going to do fixed delta time. And let's go check this out. Some things are going to happen. All right, also I'm going to change the background of my main camera. It's supposed to be something cool, like, I'm not going to do quite black, just do a really dark gray. Now if I hit play, on my player my speed is 5. I'm going to go play this. Oh, and I can see from my inspector that it is moving, but it's very, very slow. So previously we've done these like literally small games, small resolution games. And so a speed of 5 was actually pretty quick. But now we have a much larger space and we're multiplying by really small numbers. So even if we bump this up to like 50, that's better, but it's still pretty slow. If I add another 0 on the end of that, now we might be something that feels a little more like one of those arcade games that we actually want to play. So after I exit my play mode, I can bump that speed up to like 500. All right, but as you noticed, my character doesn't turn. I'm supposed to be able to turn my ship around, and it's got to face the way that I want it to. So let's go add that functionality in. So again, lower my fixed update So I need a direction for my ship to point at. I'm going to set up a float of like rotation Z, or just rot Z for short. And we're going to do some math here. So inside of mathf, there's a method called atan2. So atan2 returns the angle in radians whose tangent is y over x. The regular atan actually returns the arctangent of the angle in radians whose tangent is f. So we want this atan. We need to get an angle. So atan2. What we need to put into it are the directions that we want to go. So whether or not we're pressing up or down or left or right on the keyboard. So we can say direction.y is the first float and direction.x is the second one. And because this returns radians, that's not really something we can use right away. So we need to multiply that by mathf.rad 2 degrees, and that will convert that into something like 360 degrees. Then we can say transform.rotation equals a quaternion dot Euler, and we'll give it 0, 0, because we don't want this to rotate on those axes. We only want it to rotate on that z, which is that rot z. And after looking over my notes, this whole thing where I was being weird and saying, hey, we have a vector 3, but we're really giving me a vector 2, I was trying something else. Another solution for rotating, and this can actually just be a vector 2 direction. We only need those two things. All right, so let's try that out. So we're going to get a angle from the direction that we press, and we'll convert it to degrees, and then we set our rotation based on that math there. So now my player faces the direction that I am pressing. But if I move to the left, it always, when I let go, everything points back to the right, because that's rotate 0. So I really only want this to rotate when I've pressed a button. So what we can do is take these two lines of code and wrap them inside of an if statement. So here's something really cool that we can do with Visual Studio. Is I'm going to select those two lines of code. I'm going to right click and go to snippet and then surround with. I can surround it with an if statement. Not this first one, the one with the hashtag. We don't need that guy. Scroll down a little bit and just the regular plain if statement. And it pops if statement around it, does all the brackets for us. It gives us a condition of true, but that's not our condition. So I'm going to do a two-part condition here. One is that if my direction.x is not equal to 0, or if my direction y is not equal to 0. To get or, so like if you have two ampersands, that's and, but we want or. And there is a character called a pipe. You get to it by pressing shift and then the little backslash button that's above your enter key. So shift and that button, hit that twice and you get the or. And direction.y is not equal to 0. Oops. Okay. Gotta get my spaces right. So let's save that and go test. All right, so now, basically we're saying if we're getting any input from the keyboard, then we'll go ahead and turn the player. Otherwise, it's not going to listen, it's not going to turn the character. So if we let go, it's not getting an input because the axis is back at 0. One of them is, both of them are back at 0. Because both H and V are equal to 0 when we're not touching the keyboard, we're not turning the character. If one or more of them is equal to something other than 0, then we'll go ahead and turn the player. All right, so that's it for this video. Next, we will work on shooting. See you then.